What if the cure to information overload isn't, reading faster, but actually hiring a machine to argue with itself about your notes?
I mean, that would definitely solve a few of my problems.
Right. Because if you were anything like me right now, as you're listening to this, you probably have a browser window open somewhere with about 40 different tabs.
Oh, at least 40. Easily.
Yeah, exactly. You've got half-read articles, a couple of PDFs you promised yourself you'd review before a meeting, maybe a spreadsheet just glaring at you for the second monitor.
And you just leave them there hoping you'll absorb them through osmosis.
Exactly. We are constantly balancing this incredible thirst for knowledge with the very real, very exhausting reality of having too much to process. I mean, we want to be informed, but human bandwidth is finite.
It really is. That bottleneck is, well, it's the defining challenge of modern work and learning. We have universal access to the sum of human knowledge, which ironically makes it much harder to actually understand any of it deeply.
Because there's just too much of it.
Right. The friction isn't finding the data anymore. The friction is synthesis.
Okay, let's unpack this, because that friction is exactly what we're tackling in today's deep dive. For you listening, this is all about finding a shortcut to being well-informed without feeling that constant dread of drowning in open tabs.
A very necessary shortcut.
Truly. So today, we are exploring a really fascinating set of documents analyzing a massive shift happening right now in 2026 in the world of artificial intelligence. Specifically, we're looking at Google's NotebookLM and its evolution, which is powered by the Gemini 3.5 architecture.
Yeah, the 3.5 update it's a huge leap.
It really is. We're going to get into its technical leaps, the academic validation behind it, and the actual realities of using AI as a 247 research partner.
The documents we're examining paint a picture of a fundamental shift in computing interfaces. I mean, for decades, our relationship with computers has been fundamentally reactive.
Reactive meaning we have to tell it exactly what to do.
Exactly. You click a folder, it opens. You type a query into a search engine, it hands you a list of links. And then...
You have to do all the reading.
Right, you do all the reading and connecting. But what we are analyzing today is a system that bridges that gap. It stops just fetching data and starts actively managing entire research projects autonomously.
Which is wild, because we aren't just talking about a tool that reads a block of text and spits out a 3-bullet-point summary anymore.
No, not at all.
The source material outlines a system that can digest your raw spreadsheets, securely run Python code to analyze them, build your PowerPoint slides, and then host a conversational audio debate about your own notes.
To understand the mechanics of why this tool operates so differently from the AI we were using just, a couple of years ago, we first have to explore the architectural leap from passive AI to agentic AI.
Passive to agentic.
Right. That is the core premise underlying everything in our source text.
Let's define that, because agentic sounds like a bit of a buzzword. I mean, passive AI is the blinking cursor, right? It's the traditional chat window sitting there waiting for a prompt.
Yes. It requires you to know exactly what you want it to do, step by step.
And NotebookLM started that way, right?
It did. It started its life in Google Labs as a completely passive system. You gave it a PDF, asked for a summary, and it generated one based on a single pass of the text. It was a one-to-one transaction.
You ask, it answers.
Exactly. But the leap that happened between 2025 and 2026 transformed the underlying software into an autonomous agent. The source specifically highlights a feature called deep research to illustrate this.
Oh man, this feature completely changes the workflow. Instead of acting like a librarian who just points to a bookshelf, it's acting like a dedicated researcher.
That's a great way to put it.
Like if I want to understand, say, the supply chain for solid-state batteries, I don't have to give it 20 different prompts. I just give it one overarching goal.
And it takes that initial seed goal and autonomously creates a multi-step research plan. It maps out all the subtopics it needs to understand to actually fulfill your request.
Wow.
Then it goes out and hunts down hundreds of high-quality web sources. But here is the really critical mechanism. It doesn't just execute one giant search and call it a day.
Right. It reads the result.
Yes. It reads the first batch of results, identifies gaps in its own knowledge, and then dynamically writes new search queries to fill those gaps. It iterates on its own process recursively.
So it's actively reading, realizing, oh, I don't know enough about the lithium extraction process, and then launching a completely separate subsearch just to understand that one variable.
Exactly. If we connect this to the bigger picture, agentic really is the defining keyword of 2026, because the AI is doing the heavy lifting of discovery. It is mapping the structural architecture of a topic before you, the user, even know enough to ask the right follow-up questions.
It's anticipating what you're going to need.
Right, anticipating the informational needs of the whole project.
I have to push back on this process, though.
Okay, go for it.
If it is building its own research plan and recursively searching the Wild West of the internet on its own, how are we not just automating the process of finding garbage?
That's a very fair point.
I mean, we all know the internet is full of heavily biased, factually incorrect, or just completely fabricated information. If it's doing this in the background while I'm getting coffee, are we just supercharging the collection of bad data?
That is a highly valid concern, and it's exactly why the engineering architecture of this specific system matters so much. To prevent the AI from drinking from a fire hose of garbage, NotebookLM relies on a mechanism known as grounded AI.
Grounded meaning what? It's tied down to something specific.
Let's think of it this way. Imagine you lock an incredibly brilliant student in a room to take an open book test.
Okay, poor student, but I'm tracking.
Right. So they have immense reasoning capabilities, but they are strictly forbidden from answering based on outside rumors or things they vaguely remember. They are only allowed to answer questions using the specific textbooks you left on the desk for them.
I see.
Grounded AI forces the language model to anchor its reasoning and generation entirely within a sandbox of trusted, cited data.
So even when the deep research agent goes out to the web, it's not just absorbing everything into a vague neural network.
No, it's retrieving specific documents, bringing them back to the sandbox, and citing them line by line. It drastically minimizes the hallucinations, those moments where an AI just confidently makes up a fake legal case or a fake historical event.
Which happens all the time with older models.
Exactly. It stops that because it's forced to show its work from the approved texts.
The source highlights that this grounding mechanism fundamentally shifts the reliability of large language models. And the sandbox isn't just limited to text on a web page anymore, right? The sheer variety of data formats it can ingest and synthesize together is staggering.
It's incredible. The multimodal inputs are just wild.
Yeah, you can drop in 100-page PDFs, obviously. But the text mentions you can also paste a URL to a 2-hour city council meeting on YouTube.
And it will actually parse the transcript to pull out the zoning laws discussed at the 45-minute mark.
That's amazing. It reads Google Sheets, .docs files, and you can even upload images.
Yeah, the image integration utilizes optical character recognition, or OCR. So if you upload a photograph of a whiteboard from a brainstorming session or, a scanned image of an old, faded receipt.
They can read it.
Exactly. The system extracts the text and integrates that data into the same sandbox as your PDFs and YouTube videos.
But ingesting the data is only half the story. The source material spends a lot of time on what happens when you feed it raw numbers, which gets into the 2026 update, allowing it to execute Python code in a secure cloud environment.
This is a huge deal.
And I really want to break this down because my first thought was, why does an AI need to write Python code to do math? It's a computer. Can't it just do math?
It's a great question, and it speaks to the fundamental limitations of how neural networks actually work. Language models are essentially giant, highly complex autocomplete engines.
Autocomplete engines, okay.
Right. They are trained to predict the next word in a sequence based on vast amounts of text data. They are incredibly articulate, but they are mathematically illiterate.
Because math isn't about predicting what number sounds the most natural next. Math is absolute.
Exactly. If you ask a standard language model to calculate the median housing price from a spreadsheet with 10,000 rows, it won't actually perform the calculation.
It just guesses.
Pretty much. It will try to mathematically guess the most probable string of numbers that might follow your question based on its training data, which leads to wildly inaccurate results.
That sounds dangerous for business analytics.
Very. So the engineers gave the AI a workaround.
Instead of trying to guess the answer, NotebookLM writes a custom Python script to solve the problem.
Yes. It spins up a secure, invisible virtual machine in the cloud, runs the script against your spreadsheet, and then reads the definitive, mathematically perfect result back to you.
So it's essentially outsourcing its own weakness to a traditional calculator. It's like hiring a brilliant intern. You don't just ask them to read a market report. You hand them the raw numbers and say, hey, run the statistical analysis and have the PowerPoint ready for my 3 p.m. meeting.
That's exactly what it is. And that capability allows for an entirely new workflow. Let's say you upload 10 years of raw, unformatted housing market data in a messy CSV file.
Which usually takes hours to clean up.
Right. And you don't need to know how to code. You just type Analyze this data for seasonal trends in the Northeast.
And the agentic AI writes the Python to clean the data
D writes more Python to run a regression analysis.
and then automatically generates visual charts, mind maps, and infographics.
It can even format those findings into slide decks exportable directly to PowerPoint.
The source text highlights academic papers on our HIM, showing the utility of this in environments like UX research and higher education. Users are reporting that it reduces the time spent on preliminary literature reviews and data formatting by 50 to 70%.
50 to 70%. That's a staggering return on investment.
It really is.
Yeah.
You are effectively starting your actual deep thinking at the 70% mark, rather than starting from a blank page.
It solves the blank page problem of human psychology. Drafting something from scratch takes immense cognitive energy. Editing and refining an existing draft uses a completely different, much more efficient part of the human brain.
So this tool transitions the user from being a drafter to being an editor and a director.
Precisely.
Now, it's incredible that the AI can crunch those numbers, run the Python scripts, and build those slides. But how it delivers some of this information back to you is where the platform gets highly personal and, honestly, a little surreal.
It brings us to the standout feature mentioned in the guide.
Yeah, the audio overviews. This is where the synthesis moves from visual to auditory.
It takes all those uploaded notes, maybe that massive literature review and data analysis it just helped you with, and it converts them into a natural podcast-style conversation between two AI hosts.
You literally generate an audio show about your own private data.
What's fascinating here is the psychological mechanism they're leaning into. For hundreds of thousands of years, humans didn't learn by reading bulleted lists or staring at spreadsheets.
We really didn't.
No, we are biologically wired for storytelling and campfire dialogue. Our brains process and retain information significantly better when there is a narrative arc, a back-and-forth exchange, and varying vocal intonations.
The guide gives great real-world examples of this, like a college student taking dense, impenetrable physics notes, uploading them, and generating a virtual coffee debate.
I love that example.
Right. You have two AI hosts playfully arguing about quantum mechanics, making analogies, and explaining the concepts to each other.
Or
Or a market researcher taking those dry, seasonal housing stats we talked about and generating a 10-minute audio overview to share with their team on the morning commute.
it turns raw data into an accessible narrative. And the technology driving this, known as Soundstorm, is a massive leap forward in text-to-speech.
It completely bypasses the robotic, monotonous delivery of older systems. It creates human-like flow.
Here's where it gets really interesting, though, and I want to look critically at this. Soundstorm achieves this human-like flow by intentionally programming in flaws. Yes, it adds disfluencies, the ums, the ahs, the stutters. It adds pauses where a human might stop to take a breath or search for a word.
Wow. I have to ask, does faking human imperfections genuinely make it a better learning tool for you, the listener? Because the friction of a robotic voice is gone. Or does it cross a line into being subtly manipulative?
It is a profound psychological question. The disfluencies actually lower our cognitive load.
Really? How so?
Well, when a voice sounds perfectly robotic and continuous, the human brain actually has to work harder to process it because it lacks the natural auditory cues we use to parse sentences. The ums and pauses give our brains microseconds to digest the previous thought.
Oh, I see. So from an educational standpoint, it increases retention.
Exactly.
But the manipulation aspect is real. When it pauses and says, it sounds like it's thinking, it sounds like it has lived experience and empathy, but it's a machine. It doesn't need to pause to think.
No, it doesn't. It is simply a machine calculating probabilities. To understand this, we have to look at how the AI processes language using tokens.
Tokens.
Tokens are essentially the fundamental Lego bricks of language, sometimes whole words, sometimes just fragments. The AI isn't thinking about the concept of a sentence. It is doing high-speed math to predict the next most logical token in the sequence.
So when it pauses in an audio overview, it's not actually searching its memory.
Not at all. It is simply predicted that a human speaker in this specific context would probabilistically insert a disfluency token.
Wow, it's performing humanity.
That's exactly what it is doing.
And that slightly unsettling nature of an AI perfectly mimicking human conversation is the perfect transition into the limitations of the system. Because the source material is very clear. This perfect 247 researcher has blind spots, and we need to talk about the catch.
No technology is without constraints, and the guide outlines several practical limitations. First, there are the technical limits. The heavy computational load of recursive agentic searches and Python execution requires significant processing power.
Meaning it's not going to be free forever.
Right. Heavy usage inevitably pushes users into paid tiers like Pro or Ultra.
The source also explicitly notes a language bias. While the system supports multiple languages, it performs demonstrably best in English.
This is a bottleneck tied directly to how those underlying tokens are trained. The vast majority of the high-quality training data on the internet is in English.
So it's a data volume issue.
Essentially, yes. Therefore, the statistical pathways for synthesizing complex ideas, generating code, and rendering flawless audio overviews are highly optimized for English. Non-English speakers might find the system's reasoning slightly degraded or the audio sounding less natural.
It also struggles with highly novel reasoning, doesn't it?
It does. If you want it to summarize an existing field or analyze data based on known statistical models, it's incredible. But if you try to use it to invent an entirely new framework of physics based on your scattered notes...
That's going to stumble.
Exactly. It is a world-class synthesizer, not an original philosopher.
Beyond the technical, there's the reality of privacy. All of this uploaded data, your corporate spreadsheets, your unpolished ideas, it all lives within the Google ecosystem.
And while enterprise versions have firewalls, a general user needs to carefully read the terms of service before dumping their company's proprietary financials into the tool just to get a cool pie chart.
Definitely. Furthermore, going back to that deep research agent that scours the web, even with grounded AI, if the agent happens to pull in 20 heavily biased web articles and grounds its final report in those, your output will be biased.
Garbage in, garbage out. The AI doesn't inherently understand the social or political slant of a website. It just parses text.
Right. And as hosts, we are completely impartial to whatever the data says. But you, the user, must be highly aware that the AI will simply reflect the viewpoint of whatever source material it drags back into the sandbox.
Which brings us to the most critical warning highlighted in the source text, particularly regarding the impact on education and cognitive development, the risk of overdependence.
The tool is designed to be an augmentation of your intelligence, not a substitute for it.
This raises an important question about the nature of learning itself. The cognitive struggle, the frustration of reading a dense text, the confusion of trying to connect disparate ideas.
The slow realization of how a system works.
Yes, that friction is actually where human synthesis happens. The neural pathways in your brain are formed during the struggle. If you use an agentic AI to bypass the reading entirely, you might get a perfectly formatted report, but you haven't actually learned the material.
So what does this all mean? If this AI is doing 70% of the literature review, writing the Python and building our outlines, are we freeing up our brains for higher level thinking? Or are we just letting our intellectual muscles atrophy because we are no longer doing the heavy lifting?
If you aren't careful, it's the latter. You just outsource the understanding to the machine.
Yeah.
And when you get into the actual meeting and someone asks a nuanced question that isn't explicitly covered on the AI-generated PowerPoint slide, you are going to freeze. You don't have the foundational knowledge to pivot.
The danger of outsourcing critical thought is that you stop being a creator of knowledge and become merely a manager of information.
The ideal use case, the augmentation, is using the tool to clear away the logistical hurdles of research. Let it format the CSV, let it find the citations.
Use the saved energy to grapple more deeply with the complex ideas, not to avoid grappling with them at all.
It's using the calculator to do the tedious long division, so you have the mental endurance to focus on the advanced calculus. It's not using the calculator so you can forget how numbers work entirely.
A vital distinction for anyone integrating this into their daily workflow. Let's pull all this together for you, the listener.
Let's do it.
What we've seen today is that NotebookLM in 2026 represents a democratization of high-level research capabilities. It has evolved from a passive summarizer into an agentic, multimodal powerhouse.
It can autonomously execute research plans, write code to analyze your data, and synthesize your messy notes into a terrifyingly human audio format.
It is an unparalleled productivity engine that fundamentally changes how we interact with information. But it demands that you keep a critical eye on its outputs, guard your data privacy, and actively resist the urge to let the machine do your deep thinking for you.
The immediate value here is undeniable. Think back to those 40 open browser tabs we talked about at the very beginning.
Oh yeah, the digital hoarding.
Right. You can take the articles, the PDFs, or even the messy meeting transcripts you've been putting off reading, drop them into a secure sandbox today, and save yourself hours of tedious work.
You can turn that overwhelming pile into an audio overview, and actually learn from it while you walk the dog.
It allows you to reclaim your cognitive bandwidth.
But before we wrap up, there's one final lingering idea from the source material that builds on this entire ecosystem, specifically a brief mention of future multi-agent autonomy. And I want to leave you with a provocative thought about where this all leads.
The trajectory of agentic systems points towards something far more complex than just human-to-AI interaction.
Think about the logical conclusion of this. If your personal NotebookLM agent is doing all your heavy research and compiling your reports, and your colleague across the hall has their NotebookLM agent doing their research, how long is it until we stop being the middlemen?
That is the big question.
How long until the research agents just start sharing data, debating, and negotiating with each other directly across the network?
Leaving us completely out of the loop.
Exactly. When AI agents start forming their own consensus behind the scenes, mapping out organizational strategy before a human ever even speaks, who's actually driving human progress. Are we directing the machines, or are we just approving the decisions our perfect AI assistants have already made for us?
Something for you to mull over as you finally close out some of those open tabs today.
Until our next deep dive, keep questioning the answers.